Hi, I'm David from Electric Teaching, and I'm going to try to show you how to do a slope of a tangent line at a certain point. What we're going to use is the derivative formula using the limit process. That's what a lot of books will say, the limit process. And what formula they always have you use is this one, where I want to emphasize this is a slope. This on top is change of y. This is no different than maybe a y2 minus a y1 on top, and down here is really an x2 minus an x1. What we have is a slope. Up top we have one y coordinate right here minus another y coordinate. On the bottom we have h to represent the distance between the x's. Now, since we want to do it at maybe a certain point, like I'll show you right there, what's the slope of a tangent line at that location right there? I can see that the slope is going to be positive. I'm having trouble using my new digital pad, sorry. But I can see the slope is going to be positive. To get the exact slope is a little tricky. We want to use this formula. So what I want to emphasize is, first of all, this is just a slope. This is just a slope, just the change of y, change of x. Okay, and I'm going to create what I call a slope generating function. I'm going to create a function that says, hey, at x equal 1, x equal -1, x equals 0, whatever it is, we can tell you what the slope of the tangent line is. So after you run this function, you're going to have after you run this formula, you're going to have a derivative function. It'll tell you the derivative at any point. So let's try it. My function here is a parabola, 2x squared minus x. So I'm going to say that the derivative, which is called f prime of x, is the limit as h goes to 0. In other words, when we don't have a change of points, but we have one single point, so the change of x between point and itself is 0. So that's why we have the limit go to 0. So that means when I plug in the derivative function, the derivative function here, what we have, or derivative formula, I couldn't think of the word, sorry. I'm going to take x plus h everywhere there's an x in the equation. So sometimes I have students visualize what it is to replace the x at certain spots. So maybe even using parentheses to emphasize it. So this is f of x plus h. So this is where the 2x squared is. This is where I'm going to put x plus h and x plus h. Oops, I got a little mistake. I can see that. I accidentally wrote minus sign right here. So I can put a plus sign right there. So I have to put a minus sign right here. Now I have to take, following the instruction on the formula here, I'm going to subtract the f of x. That's subtracting the original function, 2x squared minus x. Use parentheses here, please. You're going to save yourself some trouble. All over h. So this is what I call the plug. I am simply plugging in x plus h into my x's for here and here, and that's this part of the equation. And then I'm subtracting the original function with x inside of it, and there it is. Common mistakes. People forget to square this binomial carefully. You're going to have a 2xh in the middle there that often people forget. And most importantly, negative distribution. That is something as a teacher I see problems with constantly. We need to see that this negative sign is going to be distributed to both places. When you get done, remember we're coming off of limits in probably chapter 1 of your calc book. When you get done, we're going to hopefully cancel out this h, because the reality is I wanted to plug in 0 immediately, but couldn't. If I plug in 0 here, I'd be dividing by 0. So that's why we're going to be using the limit process, or the tricks from doing the limit before. Excuse me. Let me see. It's finishing off the plug and chug part here. So the derivative is now equal to the limit as h goes to 0. Remember, I'm going to plug and chug and h equals 0 at one point. 2 times the square of x plus h. So the square of x plus h is 2x squared, 2xh, h squared. Then minus the x and minus the h and minus the 2x squared and plus the x. This is my numerator all over h. One more little cleanup here. I'm going to have the limit as the h goes to 0, okay, of 2x squared plus 2xh plus h squared. Oh, excuse me. I didn't distribute carefully. Whoops, let's try that again. 2x squared plus 4xh, well, that was close, plus 2h squared. I was so concerned with the negative distribution, I should have indicated we're going to have to distribute this carefully when you get done, but always square it first, order of operations. Then, bringing down the rest of the equation, we have minus x minus h minus 2x squared and plus x all over h. So this is the point where things should start disappearing. We should start being able to cancel things. Let me see. A positive 2x squared and a minus 2x squared is 0, so it can go bye-bye. The negative x right here and the positive x also can go bye-bye. One of the things I always check to make sure that only things left, the only terms, there's 1, 2, 3 terms there, that they all have an h in it, because I am about ready to factor out an h and cancel basically the problem, which was this h downstairs, because I couldn't plug and chug 0 with that down there. So limit as h goes to 0, as h goes to 0 of now, I'm going to go ahead and factor out the h. H factored out leaves 4x. H factored out here leaves 2h. And h factor out there leaves minus 1. A long time ago we used to call it dividing out instead of factoring out, to remind us that you are dividing by h here. That'll leave a negative 1. The other common mistake I see is people forget the negative 1. We can now cancel. We can now cancel the h there and the h there. And we can let the h, this h, go to 0. So there it goes. It's going to 0. Now, the whole entire equation, after we take the limit, has been reduced to 4x minus 1. This is what I call the slope generating function. For instance, if I wanted to know the slope at about 1 here, let's go ahead and think about this a little bit higher up so it's lined up on the 1. So the slope about right there at 1, the tangent line slope. The rate of change at that point, that's a great phrase, rate of change. That rate of change is, we'll plug in a 1 here, and for example, let me just scroll down here. For example, at x equal 1, the slope, or the derivative, the slope at the point is, I'm using m for mx plus b days, is 4 minus 1, or 3. So the slope of that tangent line at 1 would be 3. That means that the instantaneous change at that moment is basically an up 3 over 1 type of feel. But again, we're in calculus here, and we're not going up and over. We're thinking about the instantaneous change at a single point. And that's the big thing about this. Just keep in mind that the equation here is simply a slope. Change of y, change of x, but we want change of x to be a single point. Well, hopefully that helps create your f prime. This is your f prime, your derivative function, and hopefully that'll make sense for you. I'm David from Electric Teaching. Thank you for listening.